Hey guys, we're back with the 2D platformer series. Last episode we just implemented some simple movement, so left and right, on top of our player. Now what we're going to do is we're going to add some gravity in there. To do that, I will start by creating myself a small level, because now since we have gravity, or we're going to have gravity, we need to have some kind of floor. We need to be able to stick to the floor or something. So what I'll do is I'll create a new cube, and I will scale it. So first off, I moved it at the origin of the world, and then I'm going to move it down a little bit, take my scale tool pressing R, and I'm going to scale it in X, just like this. I'm going to do the same thing with some walls as well. So take your object, I'm going to take my cube again, press Ctrl C and then Ctrl V to paste it, use my rotation tool, which is the E button on the keyboard, so press E, and I'm going to move this on the Z axis. While you're moving a rotation like that, you can hold Control so it snaps perfectly to the grid, and I'm going to move it exactly at -90 in rotation. So in case you want to do it by hand, you can just go up here and change it for, say, -45 or -90. So I'm going to take this over here, move it right about there, and add another wall on this side. So duplicate again, and I'm also moving using the move gizmo, so that's W. I'm also moving holding Control so it snaps to the grid. So this is my level right now. It's nothing really good looking, but hey, it's going to work for now. Also going to move my camera back a little bit so I can see my walls, just like this. Press play. And now, as you can see, this is my player and it collides with the walls. Okay, so we got a good setup going on. Now we can start adding some gravity on top of that. And to do that, we are going to take a look at our script first. So let's go back in our script over here. Last time, if we were to read that again, last time what we did is every single frame we look, okay, are we pressing on left, or are we pressing on right, or are we pressing on nothing? After that, we debug it in the log. We're going to remove this line because it's getting annoying. We're also going to remove the other debug.log. So after we get this information, are we pressing on left or right, we are putting that information inside of our move vector, which then transfers our information we get inside of its X component. Now we know that move vector is the one that's actually taking care of moving the vector over here. So let's just do some tests over here and change the Y component for -1, just to see what happens. I'm going to press play. And as you can see, my player is now on the floor. I'm going to show you a little bit more. Let's say we put him over here. He's really high now. Press play. And as you can see, it fell down. So just like a gravity based controller, it just fell down and then it stops when it hits the floor, basically. So we need to create some kind of well, we could just leave it like that for now, but that's not going to be efficient when we want to jump a little bit later on. So what we're going to do is we're going to store that information, that Y information, we're going to store it inside of an other float, just like we did for X. In fact, let's put some comments up here. We're going to say this is the X component, or I mean, let's say value. So X value of our move vector. And now we're going to create another one, private float, that we're going to call vertical velocity. And this is going to be the Y value of our move vector. Okay, so let's start putting some values inside of that vertical velocity. To do that, let's just think a little bit about how we should handle this. So a way I propose is when our player is on the floor, we should be setting that to 0. So we should not have to deal with gravity when our player is on the floor. He should just be still. So what we'll do is there is something inside the controller character controller type called isGrounded. So it is a function that returns a boolean, so a true or false, and we're going to be using that. Actually, does it return a, is it a function? No, it's actually a property. So if we put that in between parentheses and we put an if in front of it, we now have a condition that checks, okay, is our player grounded or is he flying? So using that, we will now calculate the vertical velocity. Say our player is grounded, then vertical velocity is going to equal to 0. So we're not moving on the y-axis because he's grounded. So if our player is not grounded, then vertical velocity is going to be minus equal a certain float value, so say 1. Let's actually put that inside of a field. So I'll go up here, I'll do private float gravity is equal to 1. So vertical velocity is minus equal to gravity now. Let's take a look at, actually, well, before we go take a look at what it does in game, we have to put this inside our move vector. So take vertical velocity and replace the y component by vertical velocity. The y component of our move vector, of course. Okay, so let's go see in game what it gives us. Press play. And our vector fell down. Now we can move left to right, but we're going way too fast. So before we keep going on with the gravity stuff, we're going to slow down our character a little bit, and to do that, I'll go down in the controller.move over here, the function, and where it says move vector, I'm going to say move vector times time.delta time. Now, time.delta time is actually quite difficult to explain, but what this is going to do is it's going to make sure that your game, say you have two computers in front of you. You have one that runs your game at 10 FPS and another one that runs your game at 60 FPS. Adding that call over here, adding that times time.delta time, is going to make sure that both computer, your game runs at the same speed. Well, not your game, but your player moves at the same speed on both computer. You see that sometimes with a really old game, they didn't have that time.delta time notion. So let's say you're playing a really old game and you're running it at, say, 120 FPS. Then your character in that game goes really fast. It's because they didn't implement that time.delta time notion. All you have to remember is that we use this when we want to make sure that it runs at the same speed on different computers. So let's hit play. That's a little bit, not a little bit, it's a lot slower than it used to be, but we're going to change that using a speed modifier. So let's go up here, say private float speed, and this is going to be the speed at which your player goes. So let's say 5 for now, and where it says input.get direction or get axis, we are going to say get axis times speed, just like this. Now hit play again, and it's much more fun. Good. And another thing you maybe haven't noticed yet, but I'll make it obvious by reducing the gravity to, say, 0.05. Don't do that. We'll switch it back to 1 in a second. But we don't have linear falling speed. As you can see, it starts really slow and then an increment with time, just like real gravity. And the reason we have that is because we say minus equal here and not equal. Okay, let's put it back on to 1, and of course we'll modify these values a little bit later on when we balance our game. But if we take a look at this, this is pretty much it. Actually, this is pretty much what we want. I'll modify my level a little bit so we have some more. Actually, I'll delete the wall and I'll just resize this, and I'll add some kind of stairs to my level. So duplicate, stairs, stairs, and again. Okay, now let's hit play. My vertical velocity should be 0 now, and then we start falling again and again. Good, so now we have gravity in our game. We're getting closer to having some kind of movement mechanic inside our platformer game. So that's pretty much it for this episode, guys. Next one, we're going to tackle the jump and also the double jump while we're at it. It's really, really simple, so tag along for next episode, and I will see you next time.